Hello, Algebras. Welcome to our Algebra 1 distance learning. It is great to be able to continue with you guys, and I'm looking forward to our sessions together and working together here. I will try to go as slowly as needed, but I want to encourage you anytime if you need to write down the problem and I have to go through pretty quickly, I would encourage you and advise you to pause the video so that you can write down what is on the screen at that time and then continue. All right, well, we get to start section 7.4, solving systems by elimination. Now, just a quick recap here. If we have two sets of numbers right there, you've got two sets x plus y and another set of x plus y. We want to combine the like terms. So all we would have to do is 5x plus negative 2x, and then 4y plus 7y. And what does that give us? 5 minus 2 is 3x. 4 plus 7 equals 11y. And so there's our answer. When you simplify this algebraic expression, you get 3x plus 11y. Now let's take a look at this. This is different. This is subtraction of the two expressions, okay? So it's going to be negative, or 5x minus negative 2x. What do you get there? Remember, two negative signs become a positive. So it's going to be 5x plus 2x now. That gives us 7x. And then we have 4y minus 7y, and that's equal to negative 3y. Okay, so there's a quick review. Now we're going to take a look at two different equations, and we have to see how we can solve for two different variables using two different equations. And we can, we'll go through the examples. First, let's take a look at this one. I can take one of these equations and solve either for x or for y, and then use that to substitute back into this next equation here. So, now here they just give us the answer. The coordinate, the x is 36 over 13, and the y is 2 over 13. Now, unfortunately, I don't have the steps listed out in detail here, but let me try to talk you through this. Okay, let's say, for example, I'm going to solve for x here. So with this equation, I'm going to move the 3y over to the other side. So how do I do that? I subtract 3y. So this is going to become 6 minus 3y. And then I have 2x equals that. So now I need to divide by 2 and have the x by itself. So x now is going to be equal to 6 minus 3y divided by 2. And that's going to be my x. And then I'm going to take that and I'm going to plug it back in here for the x, because I have 3x. And then that way I can solve for y, and then that will give me 36 over 13 and 2 over 13 for y. Now, if you can try to do that on your own first, okay, solve for x, and then plug it back into the x here, and then solve for y. Try that. The elimination method means by adding or subtracting the equations or multiples of the equations, you can eliminate one of the variables and then plug that variable back into the equation and solve for the second variable. Solving the resulting equation produces the value of the remaining variable. So let's say we have x and y. If I can solve for x, like we did in the example earlier, I can substitute that equation back into the x, and then I can solve for y. Or I could do it vice versa. I could solve for y, and then plug that back into your y, and you'll be able to solve for x. Now, let's look at some examples with numbers, okay? So, example number 1, I've got 4x minus 2y equals 13, 8x plus 2y equals 23. So, I'm going to take one of these, I'm going to solve for the variable. Actually, okay, so now first we're going to combine the two equations. Negative 2y plus 2y, those cancel each other out, don't they? So that will eliminate my y's. Now I have the x's left. 4x plus 8x gives me 12x. 13 plus 23 equals 36. If I solve for x, I'm going to divide by 12, divide by 12. X equals what? What's 36 divided by 12? Yes, you got it. X equals 3. Very good. Now, I can plug in x equals 3, plug 3 back into an x, and I can choose either one of these equations to solve for y, and it would still work. So here, they've chosen 8x plus 2y, so my x is 3, okay? So I have 8x, or 8 times 3 plus 2y equals 23. So then I have 24 plus 2y equals 23. Now I can solve for y, and y equals negative 1/2. So now my solution is the x is 3, and then y is negative 1/2. And if you plug that back in to both equations, it should give you these answers and work. So you can check that yourselves. Now, the elimination method. If the coefficients of like terms are the same, the variable can be eliminated by subtracting one equation from the other. Earlier, we added the equations, and then that eliminated one variable. But now, if the coefficient of like terms are the same, you can subtract them, because when you subtract two of the same numbers, what do you get? You get a 0. All right. Now, there are two ways to solve example number 2. So, first of all, here are our two equations. Now, since 3x is the same in both equations, we're going to subtract. So, I'm going to subtract the two equations. 3x minus 3x equals 0, right? Now, 2 minus 5 gives me negative 3. And then 8 minus 14 gives me negative 6. And then I can solve for y. Negative 6 divided by negative 3 is going to give me a positive 2. Then I can plug that positive 2 back into one of the equations, and you can choose either one. So 3x plus 5 times 2 equals 14, and then you simplify that, And then you solve for x, and x equals 4/3. So for this, our solution is 4/3 and 2. 2 is a y right there. Now, the alternate method here, let's take a look at that. They multiplied all the way across this whole equation, multiplied by -1. And then that gives me an opposite. The opposite of 3x is -3x. And then so if I add those together, they're going to eliminate and cancel out. And then I'm left with the y's. So -3y equals -6 when I add the two equations there. And y is equal to 2. And then the solution is still 4/3, 2. Sometimes you should use the multiplication property of equality on one or both equations in such a way that the coefficients of one of the variables have the same absolute value. I know you're probably thinking, what? Just think back to what is the multiplication property of equality. And we'll take a look in the next example. We'll be able to see how we're going to use this.